So here's our last section on the conic sections. We're going to wrap up hyperbolas the same way we have with the others. How do you write the equations yourself? How do you prove that you have a hyperbola instead of an ellipse? So here we've been given some information starting with the foci and the transverse axis length. Remember that just like with the ellipse, the center is always halfway between any of the pairs of points they give you. So if they give you two foci or two transverse axis endpoints, vertices, whatever the case may be, if you can find the midpoint of those, that will be the coordinate of your center. So in this case, my center is going to be 0, 0, because it's halfway between the point 0, 3 and 0, negative 3, which would be starting from the origin, it would be up 3 and down 3. So halfway in between is the origin. So based on that, that means my h value is 0 and my k value is 0. Now the other thing we can do from this, since we can say the distance from the center to either of the foci that we have, that's the length c. So now I know that going from the center to the one of the coordinates, either pick 0, 3 or 0, negative 3, either way, that distance is going to be c equals 3. And then for our transverse axis length, if you compare this to the rules on the listing of all of the formulas here, the transverse axis length is the one that has a length of 2a. So for our example, that means we can say 2a equals 4. So now we know that a is equal to 2. And for finding our last value, the b value, we can use our Pythagorean theorem, which says that a squared plus b squared, which we don't know what it is equal to c squared, which is 9. So if you solve this equation, you would subtract 4 from both sides and then take the square root. So you end up with b is equal to the square root of 5. So now when we're writing the equation in standard form, since the foci are going in the vertical direction, that means this has to be one of the hyperbolas where we have the y squared minus x squared. We also know that it's always set equal to a 1, so we can fill that in right off the bat. The reason I don't have an x minus number or a y minus number is because both h and k were 0, so I don't have to worry about any of that part. So I know that y squared comes first because the foci were going in the y direction, and both the a and the c values need to come from whatever your first variable is in your equation. So since they came from y, that means y goes first. My a value we said was 2. If you square that, that's going to equal 4, because remember what we actually need is a squared. Same thing with this. We actually didn't even really need to identify that b is the square root of 5. What mattered to us was what b squared equals. So right when I subtracted 4 and said that b squared equals 5, we actually could have stopped there because that's what goes underneath the x variable. So here we have our standard form for the hyperbola with those conditions. This next example is only trickier because they didn't outright tell us the lengths. We're going to have to find those distances on our own. So if you notice on the transverse axis endpoints, instead of them saying the transverse axis length is 6, and we can just say 2a equals 6, they've given us the coordinates for the endpoints, and we're going to have to find the distance between these. You could just use the distance formula if you recall doing that. What I'll point out is it's a little bit easier than that even, because the x-coordinates aren't changing between these two. So without even using the whole distance formula, we can actually just say how far apart are -9 and -2, and that length will be our 2a value. So the distance between -9 and -2 is 7, which means a is the fraction 7/2. And then we can do the same thing with the coordinates for the foci that they gave us. Because the foci, again, the x-coordinate does not change, so we can ignore that for a second. And we can just say how far apart is -11 from 0. And that will be the length for 2c, because we're doing from foci to foci, not from foci to center, which would be c. So in this case, 2c equals 11, which means c is 11/2. And so then again, I'll get rid of this part so we can see our numbers. Also, don't forget that I told you guys you can always identify the h and the k values, the center of the coordinate, by just finding the midpoint of any of the ones that are given for you. So if we took the midpoint, it doesn't matter which one we do it to, either the foci or the transverse axis points, any pair of points they give you. If we take the midpoint of the x-coordinates here, we have -3 plus another -3 divided by 2. That's going to be our x-coordinate. And for the y-coordinate, if we average the y-coordinates, we'll have -9 plus -2. And we're going to cut that in half as well. That will be our center, which in this case is -6/2, so -3. And -9 plus another -2 is -11, so -11/2. That doesn't simplify. So since that was our center, what we've just found is our coordinate h and k. So now we know h is -3 and k is -11/2. The only thing we're still missing is the b value. So we can go back to using our a squared plus b squared equals c squared. So a squared, in this case, just multiply straight across for the fraction. 7 times 7 is 49. And in the denominator, 2 times 2 is 4. So this plus b squared will equal c squared. And again, if you're multiplying 11/2 times 11/2, you multiply straight across for fractions. So 11 times 11 is 121. And the denominator is 4. So what I'm going to have to do here is subtract 49/4 from both sides of the equation. But the good news is that means we do already have a common denominator. So we're really just focusing on the top, the 121 minus 49. So for this example, we have 72/4. But this is also the point we can stop at. We don't actually have to find the square root of this. You should still simplify the fraction though, so both of these are divisible by 2. So then you would want to call that 36/2. And these are also both divisible by 2, so this is actually equal to 18. So we don't need to find the square root of 18. We could, but remember b squared is what we're actually going to plug into the equation, so we can just stop there. So the last thing we need to pay attention to is which variable goes first. Is it the x value or the y value? And in this case, since the either the transverse axis endpoints or the foci, you can see that it's the y coordinate that's changing. That means I need to have my y value first. So I'm going to have y minus -1/2, -11/2, so y plus 11/2. And for the x value, we had h is -3, so if you subtract -3, you get +3. And remember, this always equals 1. And the a value that we got, 7/2, we need that squared. So that's going to be 49/4. That needs to go in the first denominator. And for the other value, our b squared, that 18, is going to come over here. Now, one last comment I'd give on this example, though, is we don't generally like having the fractions inside of fractions look. So this is a case where you actually would probably prefer to write this in a decimal form. So instead of writing y plus 11/2, I would instead put that as y plus 5.5 squared. And the denominator, instead of 49/4, you could actually write that as 12.25. And then the other one was okay. That one was already all whole numbers there, so that one's okay. I don't think we would give you one with fractions and numbers like that on the test, but it could come up on some of the assignments. That's why it's good to just go over. We don't really like seeing fractions inside of fractions, and this is a much harder case to try and simplify in another way. So here's our last example where we're going to go through that completing the square process again. First requirement is I need to group together the x terms. So x squared minus 10x. I'm going to leave a space for completing the square. And then I've got a minus 4y squared plus 24y. And I'm going to move the -15 to the other side of the equation. So it'll say equals 15. Now on this one, I'm already ready to complete the square. But over here on this side, remember, you can't complete the square if there's a number attached to your x squared or your y squared. So I actually need to factor out that -4 before I can do anything else. And if I take -4 out of these two terms, that'll leave me with y squared minus 6y. So that's what I'll be completing the square on in this one. And we can just bring the other one down exactly as it was. I didn't change anything there. So if we're completing the square, we take half of the middle number, which in this case is -5, square that, and you get 25. So I'm going to add 25 to both sides of the equation to keep that balance in there. And the reason for doing that is because this will nicely factor down as x minus 5 squared. This other part will be a little bit trickier because if I take half of the middle number, I get -3, square it, you get 9. But what you have to remember is we didn't actually add 9, we actually added -4 times 9. So I'm actually going to subtract 36 from this other side of the equation to keep that balance of subtracting a bigger number on this side as well. And now this will factor down as -4 times y minus 3 squared. And if we combine the like terms here, 15 plus 25 is 40, minus 36 is 4. And our last step is, remember, we shouldn't have a number other than 1 on the other side of the equation. So I'm going to divide everything by 4, which will make this x minus 5 squared over 4 minus y minus 3 squared equals 1. When I divide this middle piece by 4, the 4's are canceling. You could think of it as over 1. That's technically what you have when you have a whole number, but we don't really like to write divided by 1 or times 1. So I would just leave it in this form, but if it helps you to visualize the over 1 part, by all means, please do so. And from there, being able to draw the graph. So again, we want to start with the center of our shape, which is going to be +5, +3. So I'm going to go right 5, up 3, and draw a dot there. So that's our center, and we can label that as well. So we'll say center is 5, 3. And then for the next part, they want to know the vertices. Well, since my a value on this one is 2, and I know that we need to add or subtract it from the x coordinate because it came from underneath x. So I'm going to start with the center 5, 3, and I'm going to be going 2 in the x directions. So 2 to the right and 2 to the left. And that way you can even just look at the graph and read off what the vertices you just plotted were, or you can do it the algebraic method of adding 2 and subtracting 2 from this number. Either way, you should be getting the coordinates 3, 3, and 7, 3. So you can do that algebraically by adding and subtracting 2 from the x coordinate, or by plotting them like I did and then just looking at where your coordinates ended up. And then we also need to use the b value. So the other number we had in the denominator was 1, and if b squared equals 1, that means b is 1 as well. So b is 1, which means from the center, I'm going to go up 1 and down 1 for the b dots. And I'm just going to lightly draw in, kind of using like a dotted line here, draw in the rectangle. And I know that my asymptotes will pass through the diagonal corners. So to finish off my graph, since this one is a left and right hyperbola, the x variable is what's coming first, so it's going in the x directions. So it touches the sides of the box that you drew, and then it gets closer and closer to the asymptotes, but never actually touches it. And it does that on both sides. So this right side's kind of cut off, but you can still try to draw in the hyperbola over there as well. So that's finishing the graph off. They did also ask us to identify the coordinates of the foci though. And we hadn't determined the c values yet, so I need to go back to the formula that a squared plus b squared equals c squared, which means for our answer that c is going to be the square root of 5. So now that we have a, b, and c, and then remember we're adding c to the same value that a got added to. So a was being added to the x-coordinates, which means c will be added to the x-coordinates as well. A and c are always tied together. So if I'm adding and subtracting square root of 5 from 5, then I'll have the point 5 plus or minus, so 2 different coordinates, square root of 5, comma 3. So now we've drawn the graph, we've identified the center, vertices, and foci, and that's everything for this example. So that'll take care of the notes. Thanks, guys.